Welcome everyone to this session on training and skilling at ICW 2020. My name is Sunny Surlakar. I'm a civil engineer and a concrete technologist by profession, and also training is one of my passions. So, which is why today I'm here to talk to you about modern technical training. So this is kind of a new model, new concept based on a practical approach that we have been developing over the past couple of years, and it leads kind of a new dimension in the skilling industry for professionals, especially in the construction industry. Construction is an industry that runs a little bit different. It's a much more physical industry, and the models can't solely be online or can't solely be on the field. So pretty much we have to find a good balance between the two, and that is what we're here to talk to you about. So when we talk about why modern technical training, so little bit we'll start off with the introduction to what we are talking about, why it's needed, what are the problems seen on the site, and so on. Then we'll talk a little bit about the model, about who will benefit, like who can attend or who can work in these kind of trainings, and then we'll show you some practical ideas for execution, and then finally conclude. So, just introducing the concept to you, when this thought came about, like even for ICW 2020, like what are the problems? So basically, the thing always started off with, uh, why are we doing this? So when we talk about the modern technology in construction, so I mean that is where the problem pretty much starts off. Like the main issue is that a lot of these modern technologies are not finding their way onto the regular job site. For example, topics like modern concrete technology, say making self-compacting concretes, for example, how to use local materials more efficiently, how to make green, low CO2 footprint concrete, for example. Like all those kind of technologies are still not found mainstream applications today. Although the world is doing it, but we in India, except for maybe the bigger projects, the regular mainstream construction is not yet seeing a lot of these technologies. Also, same areas and fields like waterproofing, repair and restoration, flooring. Like there are so many mysteries. There are so many thoughts, or there are so many doubts about waterproofing and repair and flooring and how to do it right. There are so many concepts. There are so many modern materials. There are so many issues over there, but these are not being addressed, I would say, in terms of field applications. Also, areas like construction management or material technology, the Internet of Things or BIM modeling. These are often things talked about only at conferences. But why are we not seeing much more mainstream adoption of these kind of technologies, especially in a post-COVID world? These kind of things really help make our construction better. They help make it faster. They help make it cheaper, and they really help to improve the skill level of the people associated with the project. So why are we not seeing this? Even specialty areas like arbitration contracts or design, it's going means it's not yet that widespread. I mean, the professionals are still a few and far in between. So there are some problems also for the adoption of modern technology, and these range right from like these topics are not covered adequately in academic syllabi. So even at the graduate level, not many students know or are fluent with these kind of ideas. They're not popular, of course, in mainstream technology because they're also coming through or permeating very slowly. But one of the key problems in this has been the reluctance to accept modern technology. That being said, also there is a minimal exposure to these kind of modern methods, and since people don't know about it, they're very reluctant to accept it at times. So also, say lack of coded provisions is what I would say part of the problem, because we also work with BIS, but the coded provisions for new and modern methods are coming in. Of course, they're coming in, but they're coming in a lot slower. So the adoption over time, like from the time the code is made to the time it's adopted, is the time lag is pretty high. And because of this, like professionals such as graduates, designers, or site engineers, or even like at the supervisor or the labor level, then they're affected because a lot of them don't know how to deal with these new things. Another problem that normally comes up is that or say in the construction industry, we are not taking a look at what are the initial costs versus the life cycle costs. Oftentimes, people just ask, "अरे कितना पड़ता है?" So, initial cost is often the basis for making long-term decisions too. But somewhere we have to kind of look into the life cycle costing of a lot of the modern technologies. So the outcome of the problem that since these technologies are not adopted on a mass level, The problem that come up is that the constructors don't understand modern methods. Many of them actually consider the adoption of technology as a risk. What that leads to, of course, is less durability, slower construction. The construction is not as eco-friendly or doesn't have the green credits. You cannot reduce carbon dioxide footprints. So all these problems come in. Oftentimes, we've seen in practice, especially from the side of materials, that people want state-of-the-art systems. Like they want the best and the best of modern technology, but with a 20-year work history. So that is simply not possible, because the more you innovate, the newer the material is, and at some point in time, these materials need to permeate into the mainstream construction. So this is what is also hampering the entry of startup culture in construction. Today we talk about startup only in terms of software engineering, but why not startups in construction? So lack of application of engineering principles, like that again is one problem. Rely on hearsay or blind adoption of technology. These are really serious problems that the construction industry has to consult with. And because of that, there has been, I would say, minimal visible improvements in construction over a long term period of time. So I mean, construction in most, like even the rural areas, it's pretty much the same like what it did about 20 years ago. So when we started talking or discussing about these things, so we said, what does the training model actually need? So we start off with a defined syllabus. Then we look. The second part is the most important part, is development of practical study material. So study material simply does not mean a printout of the slides that you're going to be talking about. A practical study material should be like an in-depth manual, maybe 200, 250 pages, depending on what kind of course you're doing. But it should give a student or it should give a trainee complete insight into what kind of training or what kind of professional development he's looking at. Then, of course, since we are in construction, online has its limitations. So we do need classroom and practical sessions, classroom as well as industry interactions and practicals. Because without the last two parts, it is like the training or training is incomplete. We are a physical industry. Construction is a physical industry. We need to see everything. We need to see, touch, and see how it works in practice. And without that, any training remains incomplete. So, like I said, the course materials would take a look at the syllabus. So, basically, your syllabus can go across any of the topics that we saw, modern construction topics that we saw early on. And the study materials is something that a lot of development actually goes through, development work. So, for example, it has to be a combination of presentation notes, your custom detailed manual, then also, of course, other suggested reading and online resources. So you have to pretty much cover all bases when it comes to the study materials itself. In the classroom, we can cover, of course, things like theory, principles, methods, and experiences, like case studies or things like that. But along with that, the key part is the industry interaction and the practicals. This has to be done on site or in the laboratory. So in the laboratory or application labs is one place where we can demonstrate a lot of the materials. On site is where we see the actual application. But also industry interaction is important because it lets the seniors, discuss and narrate their experiences with regards to materials or design or the application part of it. So of course the formats has to be a combination of online and on-site. So online can be done for all the classroom sessions, but on-site I would say is becomes a must for the course. So, who can attend or who benefits from this kind of a modern training methodology? I would think that this is equally applicable to academia and professionals. Like based on our experience, what we think about this kind of a course is that it can supplement engineering courses in the college, for example, civil engineering courses. So it just becomes another coursework for the students to follow. It's an excellent thing for short term training programs. Like I think that's a TechWhip or TEQUIP initiative by AICTE. So it really helps training program for educators who can in turn they can improve education levels for their students. For postgraduate training or for finishing school, for example, whenever a graduate comes out of out of an engineering college, then we are not sure whether they're normally a little bit rough around the edges. So this kind of a training course can lead them to a specific line. For example, if somebody does a course on waterproofing, can follow that as a career path, and the finishing school allows him to develop skills which are very suitable for that particular line. For example, of course, we can also work with internship support. So as far as professional goes, of course, it gives them exposure to modern materials, and we have already done and taken care of these kind of courses for specifiers, for supervisors, and even for the skilled laborers, for example. But we are also working at the other level with unskilled labor. So we kind of work with them to get special regional courses, which are much more in their language, used to the materials, done with the materials that they are used to, and they're much more practical. So it has to be kind of tailor made to the kind of application that we are going to see. But the base or the aim of this entire agenda and exercise is basically training as well as certification. It's not only that okay, you come, you attend a series, and you go away, and people don't know what to do with it. So basically, we need to get into the certification of training. So it also really helps in the skill upgradation or in continuing education, because once you have the certificate means you need an evaluation, and once you have an evaluation means you have really understood the topic. It's kind of going through college all over again. So, as an idea for execution, for example, we have already tried this with the IITD assess model. Like we've developed a lot of these courses, and we have kind of delivered a lot of this kind of courses. Of course, modules of it, not the whole ones. But along with like those are the manuals that I actually saw. So they are very very healthy, like about 250 260-page manuals. Along with that, we have developed facilities, for example, whereby both the classroom training, the laboratories, as well as the application labs are there. So people can both take a look at the theory part of it, see how it's applied, and then apply it themselves. Of course, we also follow other like say in practice things or online modules. But we really prefer to work with the people. This, for example, is one of the trainings which we had, whereby people are actually testing out all the different products, like how they look in a mixture, how it is to be, say, for example, injection resins, how they're to be injected, how do you mix a waterproofing system, how do you apply it, and so on. And we take it up onto an international level as well. So with that, we can see, like with our international industry partners, so people can get a first-hand knowledge about how the machinery works, how the material works, and how we have to do it both together. We also do it on site for specific companies. This, for example, is with a known cement company in Mumbai. So we did a training course on admixtures for them. So in conclusion, like the training methodology, so what it has to look at is the development of sustainable programs, and these programs have to be accredited through a recognized institution. So what that leads to, the next step is that you're looking at CPD programs, which means continuing professional development programs. And that is the kind of model it has to follow in the long run. But to do that, also, we need a lot of other things. A lot of work goes into making one course, because you need the proper manuals, you need space for practical training, you need facilities for that one, lab training, lab testing. So you need detailed or high quality laboratories. Along with that, we have also done, and we need to take a look at professional interactions and site visits and something like that, and that has to be a mandatory part or a compulsory part of the course. Of course, a lot of these things can be tailor-made based on the level of has to be tailor-made based on the level of the people attending it. And last but not least, the certification and registry of it is a need. Like without the certification part of it, all the training, I would say, really doesn't do much, because once somebody knows that they're going to be certified for it and the certification has a value, that is where the training and the skill development or the continuing professional development will see value on its own. So with that, I would say, with this model, I would say thank you very much.